Hey everyone, welcome back to my channel Beaker and Board. In my previous video I have explained to you how to write the IUPAC nomenclature of alkenes. The details explanation of the rules along with the examples are given. Follow that so that you go through it and understand it properly. I have also provided a short video where I have given you some examples for the IUPAC of alkenes, some more examples. So let's come back to this present class. Today's class is about the IUPAC of alkenes and alkynes. So what do you mean by alkenes first of all? Alkane means carbon-carbon single bond. Alkenes, what is the meaning of alkene? Alkenes are those organic compounds. Alkenes are those hydrocarbons or organic compounds where there is at least one carbon-carbon double bond. Any hydrocarbon which contain carbon-carbon double bond in it, at least one. If it is more than one, then also it is called alkene. If at least one carbon-carbon double bond is present, then it will be called alkene. And if there is at least one carbon-carbon triple bond, then they will be called alkynes. So that means carbon-carbon double bond alkenes and carbon-carbon triple bond are called alkynes. And these two are collectively called unsaturated hydrocarbons. You must have read this in your junior classes. So hydrocarbons which contain carbon-carbon double bond alkenes and carbon-carbon triple bond alkynes are called unsaturated hydrocarbons. So, your main work for today's class is to know how to write the IUPAC of those compounds. The first thing is selection of parent chain. Whichever compound is given to you doesn't matter. Whenever you start writing the IUPAC name of any organic compound, you need to know how to find out the parent chain. Just as I have taught you in my previous video, today's class also you need to know how to find out the parent chain. It is a slightly different one from the alkenes. So, when you find the whenever you find the parent chain for alkenes or alkynes, you need to remember two conditions. The two conditions that will help you to find out the parent chain is that it should be continuous. As I have taught you how to understand the continuous chain. Continuous, I have already taught you this one in the previous class. Please go through that. Continuous, the carbon atoms should be bonded to each other. Any carbon atom which is not bonded will not be considered as continuous. So whenever you find out the parent chain, you need to know that the carbon atoms should be continuous. And the next thing is, it must contain the double bond or the triple bond. The parent chain may or may not include maximum number of carbon atom. In alkenes, what have you studied? That when you find out the parent chain, it should contain maximum number of carbon atoms. But for alkenes and alkynes, other than being continuous, you need to understand that the parent chain must include the double bond or the triple bond. If the double bond or the triple bond is outside the parent chain, if it comes in the side chain, it will not be considered as the parent chain. The double bond or triple bond must be a part of the parent chain. Like for example, see, I have given you one example. Suppose if I consider this one as A, B, C, D, E, F, G. If I consider this as my parent chain, that means starting from carbon atom A, that means A to B, B to C, C to D, D to E, E to F, F to G. If you consider this as your parent chain, what do you see? That the double bond is not a part of the parent chain. The double bond comes under the side chain. That means this condition is not satisfied. For selection of parent chain for an alkene or alkyne, the double bond must be a part of the parent chain, even if it does not have maximum number of carbon atom. See, if I consider this parent chain, we are having 7 carbon atoms. If I consider this one as my parent chain, then it has 7 carbon atoms, which is good enough, having maximum number of carbon atoms. But the problem is the double bond is outside the parent chain, which is not satisfied. Now the next thing is, in the same compound, if I select this as my parent chain, suppose if A, B, C, D, E, this is continuous as well as having the double bond. If I consider this as my parent chain, if I consider this as a part of my parent chain, then this includes the double bond. The double bond, that means A to B to C, then to D to E. It is continuous. The carbon atoms are just beside one another. They are bonded to each other and also having the double bond in it. That means this part CH2, CH2, CH3. This part comes under the side chain. So that means this one is correct, though it includes only 5 carbon atoms. This one is correct. It is having less carbon atoms in it, but still this one is the correct parent chain, not the previous one, because the double bond is outside the parent chain. The next one is, after the selection of parent chain, once you understand which one the parent chain is, the second one will be to number the chain. You have to give locant, you have to assign numbers to the parent chain. And it should be done in such a way that the carbon atom bearing the double bond or triple bond gets the lowest locant. That means for this chain, for this compound, if I number from the right hand side, it is 1. The locants come to be 1, 2, 3, 4, 5. That means the double bond is at the 2 and 3 position. If I start numbering from the right hand side, then the double bond is at the 2 and 3 position. Which one will you select? You will give the lowest locant. That means double bond is at carbon 2, is at the second carbon atom. You may say that, ma'am, the double bond is between 2 and 3. Why am I selecting 2? Just according to the lowest locant rule. You will say that the double bond is at the 2 position, not at the 3 position. Now if I take the same compound and write in this way. If I start numbering from the left hand side, then what do you see? That from the left hand side, the locant is, the double bond is at carbon 3, at the third carbon, which is wrong. As I said, you will number in such a way that the carbon atom carrying the double bond gets the lowest locant, or the carbon atom carrying the triple bond gets the lowest locant. After this, the third rule is, if the double bond or the triple bond occurs more than once, a compound is given to you. Suppose this is the example given to you. This is the compound given to you. What can you see? That this compound has double bond at 2 positions. If the compound given to you has a double bond or triple bond more than once, then you need to use di or tri. This time in this compound you are having double bond 2 times. So you need to write in this way, di-in. If it would have been 3 times, then try in. That means you need to use die, try, this kind of prefixes. This die, try, these are the prefixes. These prefixes must be present if the double bond or the triple bond occurs more than once. After this, after the third rule, next comes the fourth rule, and a very important rule. Suppose you have been given a compound where both the double bond and triple bond is present. See compound A. What do you see? That both the compound is having double bond and the triple bond at the same time. So what will you do in such case? You have to give the numbering. The locant has to be given in such a way that the carbon-carbon double bond gets lower locant. If numbering from both the sides give the same locant, that means from left hand side and from the right hand side you get the same locant. In such cases, the double bond is given the lower locant and the triple bond is given the higher locant. Because just as I said, if numbering from both the sides give the same locant, then alphabetically lower locant is given. In alphabetically E comes before, so it is given the lower locant. But alphabetically Y comes later, so it is given the higher locant. So for this compound A, let's do the IUPAC for this. How will you number? Let's see from the right hand side. Let's see if it is same from both the side or not. How many carbon atoms is it having? I have given you the bond line formula. If you have not consulted my first video regarding the organic chemistry, please see there I have explained how to understand the bond line formula. Because in most of your competitive exams as well as in your board exams, the questions come with respect to the bond line formula. So you should be good in that. So how many carbon atoms is it having? 1, 2, 3, 4, 5. So that means this is the compound. Carbon, carbon, double bond here, carbon, carbon, triple bond, carbon. I have not shown you the hydrogen atoms. You will be able to understand. All the carbon atoms are having 4 bonds. Whether it is a double bonded carbon or triple bonded carbon, it must have 4 bonds with it. So suppose this is, that means this is CH3. This comes to be CH. This comes to be CH as well. And this is CH. This is the compound given to you. Now let's see the numbering, how to do it. If I number from the left hand side, there is no side chain here. It is a simple parent chain. No side branches are there. So this is 1, 2, 3, 4, 5. That means from the left hand side the locants are 2 and 4. From the left hand side the locants are 2 and 4. And from the right hand side it is, what do you see? From the right hand side the locants are something like, at the 1 position triple bond and at the 3 position double bond. Which one will you select now? I said that if numbering from both sides give the same locant, in that case the double bond is given the less locant and the triple bond is given the higher locant. But for this example, what do you see? That from the left hand side numbering is 2 and 4 and from the right hand side the numbering comes to be 1 and 3. That means the locant from both the side is not same. Numbering from both the sides does not give the same locant. In such case, we simply follow the lowest locant rule. That means the left hand side is wrong, right hand side is correct. If from both the sides the locants are same, in such cases the double bond is given less number and the triple bond is given the higher number. But here in this example, the numbering is not the same. From left hand side it is 2 and 4 and from the right hand side it is 1 and 3. So right hand side gives you the lower locant. So right hand side is the correct numbering and left hand side is the wrong numbering. So what will you do? How will you write the, let's erase the left hand side numbering simply. What do you get? The IUPAC for this compound will be, we don't have any parent chain. If you don't remember, please go my previous video. I have given you the format how to write the IUPAC of organic compounds, any organic compound. So what is the first thing? Side chain with the locant. We are not having any side chain here. After the side chain, we move to the cyclo. We are not having any cyclic ring here. No cyclic ring is there. It is a simple chain, aliphatic chain. No cyclo. So cyclo word will be erased. So side chain with the locant, then the cyclo. After that we are having the word root. What is the meaning of word root? Word root means the number of carbon atoms in the parent chain. So here in this compound we are having a simple parent chain. No side chain is there. And how many carbon atoms are there? 5. So we will write pent. Word root pent. After that we write N or ene or ine. N will not be given. Single bond is obviously there. But double bond and triple bond is present. We will not include N here. So what will we write? Pent, it is 3 ene. Pent 3 ene and 1 ine. This is the IUPAC of this compound. This is the IUPAC name of this compound. But what do you see here? That why did I write ene first? Because ene E is alphabetically before. Ine Y is alphabetically later. So pent 3 ene comes first and then ine Y comes later. So whenever you have any compound where double bond and triple bond both are present, write ene first because ene E alphabetically comes before and ine Y alphabetically comes later. So pent 3 ene 1 ine. But there is a problem. The problem is we cannot include two vowels just adjacent to each other. Now see, ene E and ine Y both are vowels. What are the vowels? Obviously you must have read this before. A, E, I, O, U. So as you know, A, E, I, O, U are the vowels. Y is also a special case of vowel, right? A, E, I, O, U and Y are the vowels in English alphabet. So now see, ene E and ine Y, they are just adjacent to each other. They are just beside each other. In such cases, just remember two vowels cannot be adjacent to each other. Two vowels cannot be side by side, cannot be beside each other. So what do we need to do? We will simply erase this ene E. Ene E will be erased. The last E will be erased. You may say, ma'am, there is a 1 in between. We have a 1 in between. Still do we need to erase? Yes. Even if there is a locant in between, you need to erase the vowel because two vowels cannot be beside each other. So that means the name comes to be pent 3 ene. In last E will not be there. 1 ine. So this is the IUPAC name of this compound. Let's come to another example. Say for example B, compound B. What do you find here? That it is Let's number from both the sides and let's check whether the locant is same or not. If let's do the numbering from left hand side first. Let's see the numbering from left hand side first. It is 1, 2, 3 and 4, right? So the condensed formula is somewhat like this. This is the compound given to you. This is the compound given to you. There is no side chain here. Let's see the numbering. From the left hand side it comes to be 1 and 3. And if it is numbered from the right hand side, then what happens? From the right hand side it is 1, 2, 3, 4. So from the right hand side it is somewhat like this. 1 and 3 again. So in this case what do we see? That numbering from both the sides, both left hand side and right hand side, gives the same locant, 1, 3. In such case what will you do? As I said, the double bond is given the less locant and the triple bond is given the higher locant. The double bond is given the less locant. That means the left hand side numbering is correct. From the left hand side what do you get? The carbon-carbon double bond is at the carbon 1 and the carbon-carbon triple bond is at carbon 3, carbon atom 3. But from the right hand side, what do you see? From the right hand side it is somewhat like this. From the right hand side we see that it is carbon-carbon triple bond gets the carbon atom 1 and the carbon-carbon double bond gets carbon atom 3. That means the left hand side numbering is correct. The double bond gets the lower locant. Triple bond gets the higher locant. When numbering from both the sides gives you the same locant. Right hand side is wrong. So in this case, what is the name of this compound? The name of this compound comes to be, no side chain is there, so we will not bother about that. Cyclo is also not there. We will simply come to the word root. After the side chain, there is cyclo. No side chain, no cyclo. So let's move to the word root. The word root is bute, because 4 carbon atoms are there. Bute. Bute, it is 1 in. Right hand side numbering is wrong. Let's erase it. Bute 1 in 3 ine. 3 ine. So this is the correct nomenclature. If anyone writes bute 3 in 1 ine, is that correct? No. Because double bond gets the lower locant and triple bond gets the higher locant. So here I have brought some important questions that will help you to understand the IUPAC of alkenes better. So let's start with the first example. See, the question is, this is the bond line representation. All the questions are given with respect to the bond line formula. If you have not followed my previous video, please go through that and understand what is the difference between dash formula, condensed formula and bond line formula, so that you can solve any questions in future properly. So the first question is somewhat like this, and what did I say? The first rule is to select the parent chain. And how do you select the parent chain for an alkene? Whenever you are writing the IUPAC nomenclature of alkene, the first step you do is to find out the parent chain in which the carbon atoms are continuous as well as the double bonds are included in the parent chain. It may or may not contain maximum number of carbon atoms, but the double bond or the triple bond must be within the parent chain. So that means if I do the first example, let us select this as the parent chain. If this is the parent chain, then see these two double bonds are not within the parent chain anymore. You can say, ma'am, you said that the double bonds must be a part of parent chain. Now see, if you want to include all the 4 double bonds within the parent chain, is it possible? It is not. Because before including the double bond, you should see that they are continuous or not. If the carbon atoms are not continuous, you cannot include them in the parent chain. So that means if I select these as the parent chain, that means the other 2 double bond comes under the side chain. So how will you write the IUPAC name? Just do the numbering first. It is 1, 2, 3, 4, 5. So what do you do? That means the first, as I said, the format is writing the side chain first. Side chain with the locant. What do you do? See that at the 3rd carbon, 2 side chains are there. And what are those side chains called? I will provide you a separate short video where I will give you the different alkyl groups and the alkynyl groups. So what is this? That means these are the ethylene groups. The side chains are called, in this example, the side chain is ethylene. Why is it ethylene? Because see, there are 2 carbon atoms. There are 2 carbon atoms and they are double bonded to each other. So it is ethylene. So what do we say? That it is 3,3 because we always write the side chain first. 3,3 diethylene because we are having ethylene 2 times. So 3,3. You need to write the locant 2 times only. You may say, ma'am, it is on the same position, at the 3rd position. So writing the 3 only once is enough. No, it's not. You need to mention the locant twice only. So 3,3 diethylene. Then it is having the parent chain. No cyclic ring is there. So let's move to the word root. The word root is pent. 5 carbon atoms in the parent chain. So penta. Next is we are having 2 double bonds at the 1 and the 4 position, selecting the lowest locant. So penta 1, 4. Now what did I say in the previous, just swipe the video previously and see that I said that if there are more than 1 double bond, we include the prefixes like di, tri, etc. We are having 2 double bonds in the parent chain. In the same parent chain, we are having 2 double bonds. That means we need to include the prefix di. Then in. So the IUPAC nomenclature comes to be something like 3,3 diethylene penta 1, 4 diene. Now you may say, why did I write penta? I should have written pent. Why am I writing penta? Because see, penta A and di D, they are not vowels. If it would have been vowel, A is a vowel but D is not a vowel. So 2 vowels are not together. That is why it is possible to write penta. If it would have been in, then what would you have written? It is pent in, not penta in. You cannot write penta in, that is wrong. Since we are having di and D is not a vowel, so we are writing penta. If it would have 1 double bond, if you would have written in, then penta, A would not have been there. Then it would have been simply pent in. Since we are having 2 double bonds, we are including the prefix di, D. That is why I am writing penta. Now the next example, number 2. The next example is something like this. See, this is a simple parent chain. No side chains are there. No side chains are there. That means, and it is having 3 double bonds. So let's number it. The numbering comes to be something like this. That means this IUPAC name, we are not having side chain. So let's exclude that. No cyclic ring, exclude that. After that, what do we do? After that, we write the word root. What is the word root? We are having 6 carbons. So hex, hexa, because we are having three double bonds. Hexa, we are having double bonds at the 1, 3 and 5 position. So hexa 1, 3, 5. You need to mention the locant of the double bond as well. If single bond, for writing the single bond, we don't mention the locant. But for writing the double bond or triple bond, you need to mention at which carbon the double bond is present or at which carbon the triple bond is present. In this example, the double bond is present at the 1, 3 and 5 position. So hexa 1, 3, 5. Then we are having 3 triple bonds. So tri-in. Hexa tri-in. So after that, and this, remember that this type of alkenes are called conjugated alkenes. These are called conjugated alkenes. What is the meaning of conjugated alkenes? Conjugated alkene means it is something like first a double bond, then a single bond, then again a double bond, again a single bond, in this way. That means whenever two or more double bonds are separated by one single bond in between. Double bond, single bond, double bond, single bond, double bond, single bond. In this way it proceeds. They are arranged alternatively. When the double bonds, when a compound has more than one double bond, if they are arranged alternatively, if the double bonds are separated by one single bond, then they will be called conjugated alkene. Now see the next example. I'll give you more examples. See, for example, if I see this. See, this is another example. Then the name will be, if you write properly, it is buta. Since we are having 4 carbon atoms, only the single parent chain, no side chains are there. So buta 1, 4, 1 and 3. 1, 3, buta 1, 3, diene. Why di? Because it is having 2 double bonds. Now the next thing is, see, here the double bond, carbon-carbon double bond is at the C1 and C2. See the adjustment, see, it is like double bond at C1 and C2, C1 and C2. Then from double bond we are moving to single bond. The single bond is between carbon 2 and carbon 3. Then again from single bond to double bond. That means from C3 to C4. That means any compound in which 2 or more double bonds are arranged alternatively such that they are separated by a single bond, by one single bond in between. Each double bond is separated by one single bond. Double bond, single bond, double bond, single bond. Such compounds are called conjugated alkene. Remember, it's a very important topic. This will be required for your harder reactions, for your competitive exams as well. I will make videos for that. After that, number 3. See the example number 3. What is it? It is, let's do the numbering again. If we do numbering from the right hand side, 1, 2, 3, 4, 5, 6, it is 7. Having 7 carbon atoms. What do we see? That at the 3rd position and at the 5th position, we are having the side chain. At the 3rd and the 5th position, we are having side chain. So, let's see it is correct or not. From the right hand side, at 1 position, we are having a double bond. At the 3rd position, we are having a side chain. At the 4th position, we are having double bond. And at the 5th position, we are having a side chain. If we do the same numbering from the left hand side, 1, 2, 3, 4, 5, 6, 7. From the left hand side, if we do the numbering from the left hand side, then what do we see? At the 3 position, we are having a side chain. 3 position, we are having side chain as well as a double bond. 3 position, side chain and double bond. Then we are having 5th position, we are having a side chain. And at the 6th position, we are having a double bond. So according to the lowest locant rule, the left hand side is the wrong one, right hand side is the correct one, right? Because in the left hand side, we are getting the higher locant. We need to give lower locants to not only the double bond but also to the side chains. So what do we do? The left hand side is the wrong one and the right hand side is the correct one. So if you write the nomenclature, what does it become? It is something like, first we need to write the side chain. Side chain with the locant. So it is 3, 5. At the 3 and the 5 position, we are having side chains and the same side chain. 3, 5 dimethyl. Both the side chains are methyl, so dimethyl. You need to provide the locant as well. After that, 3, 5 dimethyl, no cyclic ring is there. After that, we'll move to the word root, hept. Hepta, because we are having 2 double bonds. Hepta, because we are having 7 carbon atoms. See, in the word root, will include hepta, 7 carbon atoms in the parent chain. Then, hepta 1, 4 diene. 1, 4 diene. Now, what did you see? That means the double bond is present at the 1 carbon and at the 4 carbon. So 1, 4 diene. Now what kind of alkene is this? This is also having 2 double bonds. So what kind of alkene is this? This is called isolated diene. Isolated alkene, or since it is having 2 double bonds, so it is isolated diene. Why is it isolated? Isolated because the double bonds are far apart from each other. See, here what is it happening? Double bond. Then from double bond, we are having 2 single bonds in between. This is one double bond. Then this is one single bond. Double bond, single bond. Again, this is another single bond. Then again we are having a double bond. That means double bond to double bond. That means if 2 or more double bonds are widely separated from each other, are far apart from each other and are separated by many single bonds, those will be called isolated alkene. Let me give you another example. I am coming to some examples, more example. Let me solve the other 3 other examples first. See the fourth one. The fourth one. What do you see? This is an alene. This is called alene. Why is it so? Because they are just together. The double bonds are together. How do you name this? This is called alene bond. Double bond and double bond. 2 double bonds just adjacent to each other. They are not separated. 2 double bonds just adjacent to each other. They are not separated. They are together. They will be called alene. And how do you name it? No side chain is there. So obviously only the parent chain. So it is prop. Having 3 carbon atoms. So prop. Prop, propa. Propa. Then it is 1, 2. See, name it. It is 1, 2, 3. Right? So propa 1, 2. Diene. 1, 2 diene. After that, the 5th example. What can you say about the 5th example? The 5th example, how do you name it? Let's see the numbering first. If I start from this side, this is 1 carbon, this is another carbon, this is the bond line representation. I hope you can understand this. This is how it looks. This is how it looks. So let's find the parent chain first. The parent chain is somewhat like this. It is, I hope you have understood the bond line formula. Now see, the parent chain is somewhat like, we are including the parent chain as we are including the triple bond as well as giving maximum number of carbon atoms. See, the triple bond is included, right? And also the maximum number of carbon atoms are included. So what do we call? This is the parent chain. This two forms the side chain, each having 2 carbon atoms. This is 1 carbon, this is 1 carbon. Each side chain is having 2 carbon atoms. Chlorine is also the side chain. I hope you can understand this. So let's start the numbering first. How to do the numbering? Numbering will be done in this way. Let's start. How to do? It's 1, 2, 3, 4, 5, 6. This is the numbering. So what does it become? At the third position, we are having chlorine. You try the opposite thing. You try the other way around and see if lower locant is possible. So what do we get? At the third position, we are getting chlorine. And at the third and fourth position, we are getting the ethyl groups. We are getting the ethyl groups. So what do we say? We write this as 3-chloro side chain with the locant in alphabetical order. 3-chloro, then 3,4 diethyl. What do we see? That at the 3 and the 4th position, we are having ethyl group. See, the side chain is having 2 carbon atoms. So ethyl. 3-chloro, 3,4 diethyl. Why did I write chloro? Because chloro C comes first. 3,4 diethyl. Then it is hexa. Not hexa because only one triple bond is there. So hex 1 ine or hexine. Hexine. So it is something like this. It is 3-chloro 3,4 diethyl hex 1 ine. It is having only the triple bond. If you try the opposite way around, if the numbering is done in the other way, if I try the numbering in the other way, see, if this is 1, 2, 3, 4, 5, 6, then it is getting the higher locant. We will give the lower locant, right? Now the next one, the 6th example. What do you see in the 6th example? See, let's do the numbering now. Let's see from the left hand side first. 1, 2, 3, 4. This is the 5th carbon, 5. 5th carbon. And that means from the left hand side, the locants are 1 position double bond, 3 position 2 bromine atom, so 3, 3. And 4th position, we are having the triple bond. At the first position, we are having the double bond. At the 3 and 3 position, we are having the bromine atoms. And at the 4th position, we are having the triple bond. If we do the numbering from the right hand side, then what do we get? It is 1, 2, 3, 4, 5. From the right hand side, it becomes 1 position, we are having the triple bond. 3 position, we are having the bromine atoms. And at the 4th position, we are having the double bond. That means 1 position, we are having triple bond. 3 and 3 position, we are having bromine atoms. And 4th position, we are having the double bond. See, that means from both the left hand side and right hand side, the locants are same. I have already told you that if numbering from both the sides gives you the same locant, then the double bond gets the lower locant. Double bond will be given less number and triple bond will get the higher locant, which means that the right hand side numbering is wrong. Always give the lower locant to the double bond. When? If numbering from both the sides gives you the same locant. Right hand side numbering is wrong. Let us erase the right hand side numbers. So what do we write? It is somewhat like this. The IUPAC turns out to be, first of all, it is 3. Okay, fifth position we are also having the chlorine atom. Just a minute. Fifth position we are having the chlorine atom as well. So right hand side, let's see once. Right hand side, if we do the right hand side once again, it is 1, 2, 3, 4, 5. So it is 1 position chlorine, 1 position triple bond, 3 position we are having the bromine atoms, and the 4th position we are having the double bond. Always the double bond is given the lower locant. Double bond gets more preference. Double bond gets more preference. So what do we see? The right hand side numbering is wrong. Left hand side is the correct one. So let's erase it. Right hand side will be the wrong one. So let's write the IUPAC now. So it is 3,3 dibromo. Bromine B comes first. Alphabetical order has to be followed. First, always name the side chain. 3,3 dibromo. Then it is 5-chloro. 5-chloro. We are not having any more side chain. The 2 bromine atoms and the chlorine forms the side chain. After the side chain, let's move to the word root. 5. So pent. In E comes first. So pent 1 in 5. Now 4, not 5, it's 4. Pent 4 ine. In E, last E will be erased. I hope you know that. The last E for in will be erased because 2 vowels cannot be together. So it is 3,3 dibromo 5-chloro pent 1 in 4 ine. Now let me give you another example of an isolated diene. Isolated alkene. Isolated alkene. What is the meaning of this? Isolated alkene means the double bond or the triple bonds are far apart from each other. Far apart from each other. They are not at all together. They are far apart from each other and are separated by many single bonds in between. See, for example, if I say you this example, what kind of, see, this is also a diene. There are 2 double bonds here, but the 2 double bonds are widely separated. Here, this is 1 double bond. Then this becomes a single bond. Again, this is a single bond. This again forms a single bond. And this is the double bond. That means, what is the sequence? Double bond, single bond, again single bond, then single bond, again then we are having double bond. So the 2 double bonds are widely separated from each other, are far apart from each other. So that is the meaning of isolated alkene. So this is my end for today's class. Next class, I will teach you how to write the IUPAC nomenclatures of compounds having functional groups. There will be 2 videos for that. Compounds having 1 functional group and compounds having multiple functional groups. Stay tuned for my next class. If you like the class, please like, share and subscribe. Thank you.